Hi there. In the previous video I explained how to work out the inverse of a 3x3 matrix, and I'm going to use the idea of the inverse of a 3x3 matrix in order to show you how to solve simultaneous equations with the aid of the inverse. Okay, so let's have a look at this example. So let's go to the first prepared screenshot. Now in this screenshot I have a question. So the first part of this question is to find the inverse of the 3x3 matrix A. So A is given by 2, 1, minus 1, 1, minus 1, 2 and 3, 4, 1. And in part B of this question we're going to use this inverse to solve the following system of equations. So the first equation reads 2x plus y minus z equals 5, x minus y plus 2z is equal to 1, and the last equation is 3x plus 4y plus z is equal to 10. Okay. Now in the previous video I showed you a way to work out the inverse of a 3x3 matrix, so this is one of the ways to working out the inverse. And step number one, is to work out the determinant of your matrix. So this is what I did over here. So I've worked out the determinant of A, okay? And I worked out the determinant using the first row of this 3x3 matrix. And remember, the signs associated with the first row are plus, minus and plus. So I use the first row to work out the determinant, and the determinant of A should be minus 20. Now step number two to working out the inverse is to find the transpose of the matrix. So what I normally do is I first work out the transpose of your matrix. So for the transpose, remember, the rows of your given matrix will become the columns of your transpose matrix. So the first row, 2, 1, minus 1, will be the first column, 2, 1, minus 1 of your transpose matrix. Second row, 1, minus 1, 2, that will be the second column, 1, minus 1, 2 of your transpose matrix. And finally, the third row, 3, 4, 1 of your matrix A will become the third column, 3, 4, 1 of your transpose matrix. Okay. Using your transpose matrix, the second part of step 2 is to work out the adjoint of your matrix. And remember, in the previous video, you first write down the sign associated with the element of the 3x3 matrix. So for the first row, the sign associated with the first element is plus. Okay. And then write down the minor of that element. So then I worked out the minor of the first element, and I had the determinant of minus 1, 4, 2, 1. Okay. Let me take another example. So for the second element of row 1, the sign associated is minus. So write down the sign associated, and the minor of that element is 1, 4, minus 1, 1. And for the third element of row 1, sign associated is plus, and then write down the minor of that element. So the minor should be the determinant of 1, minus 1, minus 1, 2. Okay, so you continue this process for row 2 and row 3. So I had my adjoints to be minus 9, minus 5, 1, 5, minus 5, 5, minus 5 rather, and 7, minus 5, minus 3. And finally, once you have your adjoint, step 2 is completed, and in the final step, step 3, to work out the inverse of the matrix, remember the result, it's 1 over the determinant of that matrix multiplied by its adjoint. So the answer for the inverse of A, I had minus 1 over 20, multiplied by the adjoint, minus 9 minus 5, 1, 5, 5 minus 5, 7 minus 5 minus 3. Now you could go the extra step and multiply every single element of that matrix by the scalar minus 1 over 20 outside. So you could go the extra step, okay? So that completes part A of this problem. Now part B, to solve this system of equations, what you need to do firstly is you need to write that system in matrix form. Okay, so in a previous video I showed you how to write systems of equations in matrix form. Okay, that video was titled Pre and Post Multiplication of Matrices. So if you haven't watched that video, be sure to watch that video. Okay, I'll provide a link to that video in the description below. Okay, so first write that system in matrix form, and in order to work out x, y and z, remember you need to pre-multiply the equation by the inverse of the coefficient matrix on the left hand side of that equation. So the coefficient matrix is 2, 1, minus 1, 1, minus 1, 2, 3, 4, 1. So if you multiply that matrix equation by the inverse of that matrix, you can calculate x, y and z as a result. So x, y and z would be the inverse of the matrix multiplied by the column matrix 5, 1 and 10. Okay, now I want you to note that we did calculate the inverse of that matrix in part A of the problem. So for the inverse, remember we had minus 1 over 20 multiplied by minus 9 minus 5, 1, 5, 5 minus 5 and 7 minus 5 minus 3. So I used that inverse in order to work out x, y and z, and by multiplication I had a final answer for x, y and z to be 2, 1 and 0. Okay, so that is the procedure in order to solve simultaneous equations using matrices. So I hope you found this video helpful. Okay, do related practice questions and I hope to see you soon. Thank you.